Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 2, that is Electrostatic Potential and Capacitance. From basic to advanced level, for board, JEE, KCET, and NEET. Only subscribed one can get PDF. So watch till end, don't forget to comment, share, subscribe the channel. In previous class, we studied electric potential, potential difference, electrostatic potential energy, expression for potential due to a point charge. That video link is given in description, don't miss it. Today, starts with expression for potential due to an electric dipole. Let's start. Derive an expression for potential due to an electric dipole. Proof. From the figure. Consider an electric dipole AB having the charges plus Q and minus Q separated by a small distance to A. Let O be the center of the dipole and M be the point at a distance r from O. Let theta be the angle between dipole axis and the line joining the point and the center of the dipole. R1 is equal to distance between plus Q and M. R2 is equal to distance between minus Q and M. Therefore, potential due to plus Q at M is V1 is equal to 1 by 4 pi epsilon naught Q by R1. Mark as equation 1. Similarly, potential due to minus Q at M is V2 is equal to minus 1 by 4 pi epsilon naught Q by R2. Mark as equation 2. Potential due to dipole at M is the sum of potentials due to charges plus Q and minus Q. Therefore, V is equal to V1 plus V2. Substitute equation 1 and 2 in above equation. We get V is equal to 1 by 4 pi epsilon naught Q by R1 minus 1 by 4 pi epsilon naught Q by R2. On taking terms common, we get V is equal to Q by 4 pi epsilon naught into bracket 1 by R1 minus 1 by R2. Mark as equation 3. From triangle AOM and BOM. R1 square is equal to R square plus A square minus 2AR cos theta. And R2 square is equal to R square plus A square plus 2AR cos theta. Therefore, R1 square becomes, take R square common, we get R1 square is equal to R square into bracket 1 plus A square by R square minus 2 cos theta by R. If R much greater than A, then A square by R square can be neglected. Therefore, R1 square is equal to R square into bracket 1 minus 2 cos theta by R. Therefore, R1 is equal to R into bracket 1 minus 2 cos theta by R to the power 1 by 2. On taking reciprocal, 1 by R1 is equal to 1 by R into bracket 1 by 1 minus 2 cos theta by R to the power 1 by 2. Therefore, 1 by R1 is equal to 1 by R into bracket 1 minus 2 cos theta by R to the power minus 1 by 2. Using binomial theorem, we get 1 by R1 is equal to 1 by R plus A cos theta by R square. Mark as equation 4. Similarly, 1 by R2 is equal to 1 by R minus A cos theta by R square. Mark as equation 5. Substitute equation 4 and 5 in 3, we get V is equal to Q by 4 pi epsilon naught into bracket 1 by R plus A cos theta by R square minus into bracket 1 by R minus A cos theta by R square. That is equal to Q by 4 pi epsilon naught into bracket 1 by r plus a cos theta by r square minus 1 by r minus a cos theta by r square. On simplifying, we get V is equal to Q by 4 pi epsilon naught into 2a cos theta by r square. But 2a into Q is equal to P. Therefore final answer is V is equal to 1 by 4 pi epsilon naught into P cos theta by r square. This is the expression for potential due to dipole. Note 1. If theta is equal to 0 degree or 180 degree, then cos 0 degree is equal to plus 1 and cos 180 degree is equal to minus 1. V is equal to plus or minus 1 by 4 pi epsilon naught into P cos theta by r square. This is the expression for potential at a point on the dipole axis. Note 2. If theta is equal to 90 degree, then cos 90 degree is equal to 0. Therefore, V is equal to 0. Potential at any point on equatorial line is 0. Next, compare the variation of electric potential and electric field with distance. The graph shows the variation of potential V with R and field E with R for a point charge Q. They vary as V inversely proportional to R and E inversely proportional to R square. Here, if Q greater than 0, then V greater than 0. Both Q and V are positive. If Q lesser than 0, then V lesser than 0. Both Q and V are negative. If R is equal to infinity, then V is equal to 0. Potential is 0 at infinity. Next, to find potential due to a system of charges using superposition principle. Statement: the total electric potential at a given point due to a group of charges is the algebraic sum of all the potentials due to all the charges. Let Q1, Q2, Q3 up to Qn be the point charges placed at distance r1, r2, r3 up to rn respectively from point P. The potential at P due to Q1 is V1 is equal to 1 by 4 pi epsilon naught into Q1 by r1. The potential at P due to Q2 is V2 is equal to 1 by 4 pi epsilon naught into Q2 by r2. The potential at P due to Qn is Vn is equal to 1 by 4 pi epsilon naught into Qn by Rn. According to superposition principle, net potential at P is V is equal to V1 plus V2 plus V3 plus so on plus Vn. Substitute values, we get V is equal to 1 by 4 pi epsilon naught into Q1 by R1 plus 1 by 4 pi epsilon naught into Q2 by R2 plus so on plus 1 by 4 pi epsilon naught into Qn by Rn. By taking terms common, finally we get V is equal to 1 by 4 pi epsilon naught, summation of I is equal to 1 to n of Qi by Ri. Note 1. Potential due to a charged spherical shell at a point outside the shell is V is equal to 1 by 4 pi epsilon naught Q by R. Potential at the surface of spherical shell. R is equal to R. V is equal to 1 by 4 pi epsilon naught Q by R. Potential inside the shells is equal to potential at the surface, whereas electric field inside the shell is 0. This ends today's topic. Don't forget to subscribe the channel for more updates.